When clinical trials report that psychiatric drugs offer only marginal benefits over placebos, we usually draw a biological conclusion: the drugs are weak. But that assumes the foundation holding up those trials is solid. We need to ask a structural question. What if the medications work and the measuring instrument is simply broken? For decades, critics of psychiatric diagnosis have aimed their fire at a concept called validity. They ask if diagnostic categories like depression or schizophrenia reflect true biological joints in nature. This diagram charts the two fronts of the diagnostic debate. On the left, the validity argument is represented as a cloud. Debates over validity are philosophically contested and interminable. Defenders can always argue a category is provisional or waiting for better neuroscience. Look at the right side, highlighting reliability. Reliability is an empirical measurement claim. If a thermometer gives completely different readings to 3 different nurses, no theory of thermodynamics can save it. If the instrument fails to return the same reading twice, the data is useless. In psychiatry, the reliability question is purely practical. When presented with the exact same patient, do 2 competent clinicians actually assign the same diagnosis? According to the field's own custodians, the primary diagnostic manual frequently fails this basic test. This blueprint maps out what we call the epistemic waterfall. We are going to track how failures at the very top of the diagnostic pipeline, unreliable classification, cascade downward, create structured variants, and ultimately poison clinical data. By tracing this flow, we will see how unreliable clinical classification mathematically dilutes treatment efficacy. The weakness of psychiatric evidence is a structural artifact created by the very system used to measure it. In 1980, the publication of the DSM-3 introduced operationalized symptom checklists. The psychiatric field celebrated this as a definitive victory, believing these explicit criteria had permanently secured diagnostic reliability. This graphic illustrates the reality check delivered by the DSM-5 field trials in 2013. Earlier trials used idealized research settings and structured interviews that inflated agreement. The DSM-5 trials measured what happened when clinicians used their usual clinical methods on representative patients. The researchers looked closely at the 2 highest volume adult diagnoses in the world: major depressive disorder and generalized anxiety disorder. This chart plots clinical volume against diagnostic concordance. Look at the upper left red quadrant. Major depressive disorder and generalized anxiety disorder, the absolute core of global psychotropic prescribing, landed squarely in a deeply problematic concordance band, with a kappa score of roughly 0.32. The DSM-5 task force branded a 0.32 score as questionable, but as this comparison shows, that is a generous rebranding. Under the stricter historical conventions used across science, those exact same numbers are classified merely as fair. The pooled averages are bad enough, but digging into the specific clinical sites reveals a more alarming discovery. This graph isolates bipolar I disorder. One site achieved a highly reliable kappa of 0.73, another failed with 0.27. Using the exact same manual, they produced a massive 0.46 difference. Where a patient is assessed predicts their diagnosis, better than the actual criteria. If location dictates the outcome more than the symptom checklist, criteria fail as standardizing instruments. They are simply acting as blank canvases for local clinical culture. If diagnostic disagreement were purely random noise, it would be a frustrating statistical issue. It would lower precision, but it wouldn't create a systemic justice problem. The residual variance in these diagnoses patterns by patient demographics. A 2018 meta-analysis by Olbert and colleagues examined schizophrenia diagnosis rates in the United States. They found Black individuals receive the diagnosis at nearly 2.5 times the rate of white individuals. For half a century, the standard technical remedy for poor reliability has been instrumentation. The prevailing theory is that forcing clinicians to use highly structured, standardized assessment interviews will effectively remove human bias. This chart tracks odds ratios of unstructured versus structured assessments. The crucial finding: utilizing structured instruments completely failed to close the racial disparity gap. Unstructured assessment was 2.43, structured was 1.77. The statistical difference is not significant. The gap remains. This indicates that bias operates at a subterranean level the instrument cannot reach. Discretion happens in how clinicians interpret lived experience, what they classify as a culturally embedded belief, and how they frame the patient's narrative. Standardizing the clinical interview does not eliminate systemic variance. Entire cohorts of patients are systematically miscategorized before ever reaching the door of a clinical trial. This brings us to the final stage of the epistemic waterfall. We have to ask what happens when these unreliable, structurally biased diagnoses are used as the entry criteria for randomized clinical trials. The math here is governed by a core epidemiological concept called non-differential misclassification of exposure. This occurs when diagnostic error is unrelated to the actual outcome you're trying to measure. Look at the attenuation funnel. Enrolling based on unreliable criteria like major depression randomizes a completely heterogeneous mixture of patients into study arms. Participants without the true target condition act as dead weight, mechanically diluting the treatment signal in the active arm. This dilution effect predictably forces the estimated effect size of the intervention toward the null. It artificially masks true efficacy. This seesaw graphic illustrates a crucial caveat. While massive biological interventions survive misclassification, the dilution effect devastates small effect sizes, like antidepressants. This predicts that reliable constructs like PTSD should recover larger effect sizes than MDD. Yet this obvious meta-regression remains unexamined. The famously modest effect sizes of psychiatric pharmacotherapy aren't simply biological facts about the drugs. They are, in large part, measurement artifacts born from a broken classification system. Acknowledging this measurement crisis does not equate to abandoning psychiatry. We have to establish firm epistemic guardrails around what this data actually means. Imperfect measurement does not mean diagnoses are useless. Radiology and histopathology function with similar kappas, and categories still point to real suffering. Crucially, this doesn't mean psychiatric drugs fail. True effects for correctly classified subgroups might be significantly larger than pooled estimates suggest. But this data does expose a structural hypocrisy. The incumbent psychopharmacological paradigm routinely demands rigorous evidentiary standards from alternative frameworks that its own foundation cannot mathematically satisfy. This visual contrasts the incumbent psychopharmacology system as a solid tower and alternative frameworks as a skeletal frame. Challengers are forced to prove their efficacy in trials that enroll against the exact same unreliable diagnostic criteria that the incumbent system fails on. Fixing this requires minimal, unglamorous interventions. First, all future clinical trials must explicitly report the reliability of their enrollment assessments, just as a lab reports assay precision. Second, clinicians must ethically disclose this measurable diagnostic uncertainty to patients, a necessary component of informed consent. Treating the current diagnostic system as a neutral, flawless scientific baseline is a methodological error. True scientific rigor requires epistemic honesty about what the field's own data says about its broken measuring instruments.